Okay. So until now we have been learning regression equation from actual mean. So directly we will calculate arithmetic mean, that is x bar and y bar, and then we will calculate the regression equations by using the regression equations in this format. Okay. Now let us take the assumed mean. Let us consider the assumed mean and we will solve the problems. Now, in which case we will consider assumed mean? The assumed mean will always be considered whenever the actual mean has decimals or if you have fraction. So if your x bar is not a whole number and if you're getting any points in that, if you're getting any decimal points, then in that case you have to go for assumed mean. Okay, and when you take assumed mean, you have to find out the deviations from assumed mean, and then all the calculations of x square, y square, x into y, everything will be done. But here the notations will differ a little. That's all. That is the only thing that you will have to understand. Okay, now let us compare the actual mean and assumed mean and understand the notation. Now, in your actual mean, you will have xy, that is the data. Here also you will have xy. Okay, this is x is separate, y is separate. Next, you will find the deviations, that is small x is equal to x minus x bar. Correct? Now, in this part or in this assumed mean, you will be finding out dx, deviations from x. There's a small x again, deviations from x. That is nothing but x minus assumed mean. Here it is just small x. Here you will have it as dx. Now coming to y, small y is equal to y minus y bar. This will be the deviation from y for the actual mean. When it comes to assumed mean, it is dy, which is nothing but y minus assumed mean for y. And this is assumed mean for x. So here it is called as dx and dy. Okay. And after this, you are going to calculate the x square, small x square and small y square you will calculate. But for the same small x and small y, we call it as dx here. So you will calculate dx square and dy square. And finally, you will calculate x into y under actual mean. But the same x into y here is called as dx and dy. So you will multiply dx and dy in the assumed mean. Here also you will have n number of items. Here also you will have n number of items. This is same. So this is the comparison with regard to notations between the actual mean and the assumed mean. Rest all the procedures, everything is same. Fine. So let us see the formula, what is to be considered. So before that, did you all understand this comparison of notations? You should not get confused. When you find out sigma x by n, if you get a whole number, then go with the actual mean, no problem. If you are getting point, let's say you are getting 52.758, don't round it off. If you're getting points like this, go for assumed mean calculation. So that is the only way which you will be able to understand if you have to take actual mean or assumed mean. Any doubts in the until here? Did you all understand? Okay, so let us see what is the formula that we have to consider here. When assumed mean is taken, regression coefficient of y on x, that is byx, is calculated in this way. So if you remember the correlation formula, this is all similar to correlation formula. So first, y on x. If you see this coefficient, you should be able to realize this is y on x. first you have y. So n into sigma dx dy minus sigma dx into sigma dy whole divided by n dx square minus sigma dx whole square. So if you remember, this is very similar to your correlation equations, correlation formulas. So we were also solving correlation. We were also finding correlation from assumed mean, and at that time also we had used similar formula. Okay. Now on the contrary, if the regression equation is x on y, so this is y on x. See, first you have y, here you have x, so this is x on y. Now in this case, n into sigma dx dy will be same. Here also sigma dx into sigma dy will be same. So numerator is same in both of the equations. What that will change is in the denominator. So n into sigma dx square is there for y on x. For x on y, it is y square. Okay, n into sigma dy square minus sigma dy into whole square. Okay, so this is the formula that we'll be using to calculate the regression coefficient for y on x and x on y. And this all notation I have already explained it to you. Okay, so let us get into the problem directly to understand how to solve it. The following table shows age, that is x. They have only given it as x. So age is denoted as x and blood pressure is denoted with y of 6%. There are 6 people data that are given to us. So we have x and we have y. So x is nothing but age, y is blood pressure of those people. Obtain two regression equations. See, clearly the question states two regression equations. Such questions will come for 14 marks. So you have to solve. It is very easy to solve if you know how to do it. So to know how to do it, you have to analyze the question properly. Okay. Obtain two regression equations. Also find the expected blood pressure of person who is 50 years old. Okay, so they have given us the y value. Blood pressure is y, correct? No. They have asked us to find the blood pressure. Age is 50. So they have given us x. So they have given us the value of x. So if x is equal to 50, what is y they are asking us? So if you see the question, you will not know if it is assumed mean or actual mean. So what we will do first is, we will calculate sigma x by n first. We'll calculate x bar and y bar, and we will see what the answer will be given, or what is the answer that you will get. Okay, so first the tabular calculation. Simple heading, formulation of regression equation. That's all. Formulation of regression equation. Then x is equal to, copy down all of the data from x, and y, copy down the data from y. Now you're supposed to find out sigma x and sigma y, that is add all of these values. Now let us find out x bar. Sigma x by n, that is x bar. What is sigma x? Total is 317 and the number of data that we have is 6. Now can you say me what is the answer for x bar? Calculate and say me what is the answer for x bar. How much do you get? 317 by 6. Quickly. Okay, one is getting 53, one is getting 52. So I'll go with majority. 52.83. Okay, you are getting a decimal. Clearly, you are getting a decimal. Okay, same thing. Let us find out the value for y bar. Y bar 380 divided by 6. Find the value. One we got 52.83. Find the other value. 63.33. Okay. 63.33. So in both of the cases, both x bar and y bar, in both the cases, we are getting decimals. Correct? So that is the main reason why we wanted to solve this problem using assumed mean. Okay? So x bar also you get a decimal, y bar also you get a decimal. So here it means there are fractions. So that is why that is the main reason we will be using assumed mean here to calculate. Did you all understand how to check for assumed mean and the actual mean? Okay. So moving further, we have to assume one of the number to be assumed mean here. And here we have taken 52. That is the first number. See, I always told you that you can take any number from this as assumed mean. Okay. So here they have considered 52 as assumed mean for x. And for y, they have considered the last number, that is 60, as assumed mean. Okay, there is no rule it has to be first or the last. You can take any number. It is mostly the central number that you can take, but since it is an even number, you don't find the exact center number. Okay, so you can consider any number as the assumed mean out of x values only. So here we have taken 52. So after selecting the assumed mean, now let us find out the deviations from that. So dx is equal to x minus 52. So 52 minus 52 is 0. 45 minus 52 is minus 7. 36 minus 52 is minus 16. 72 minus 52 is 20. 65 minus 52 is 13. 47 minus 52 is minus 5. Use the calculator, quickly find out the differences. And once you add all of these, that is sigma dx. Sigma dx is nothing but 5 because you have both plus as well as minus values. So you get 5. Now similarly, let us find the deviations from y. That is, for y here, I have considered 60 as the assumed mean. So when I consider 60 as the assumed mean, y minus 60. So 62 minus 60 is 2. 53 minus 60 is minus 7. 51 minus 60 is minus 9. 75 minus 60 is plus 15. 79 minus 60 is 19. 60 minus 60 is 0. So here sigma dy is nothing but 20. Okay, here sigma dx, that is total, was 5, and for sigma dy it is 20. Now once we found out the deviations from the assumed mean, now let us square that deviations. So this sigma dx, you have to square all of them, which means multiply it with the same number itself. 0 into 0, 0. Minus 7 into minus 7, 7 sevens are 49. Minus into minus is plus. 16 into 16 is 256. 20 into 20 is 400. 13 into 13 is 169. 5 5s are 25. So we got dx square. This is deviation from the assumed mean and we have squared it. So the total of that will be 899. Next, dy square. The deviations from y what we have taken here has to be squared. So 2 2s are 4, 7 7s are 49, 9 9s are 81, 15 15s are 225, 19 19s are 361, 0 into 0 is 0. We have just multiplied the same number with itself to find the squares. And then add all of these numbers, you get 720. Sigma dy square is 720. Okay, so until here, what all did we find? We considered x and y. We found out the assumed mean. We considered the assumed mean from x and y. We took the deviations, that is dx and dy, and we squared the deviations dx square and dy square. Okay, and finally we'll have to multiply this deviation dx into dy. So dx into dy is, just see these two columns. 0 into 2 is 0. Minus 7 into minus 7 is 49. 16 into 9, minus 16 into minus 9 is 144. 20 into 15 is 300. 13 into 19 is 247. 5 into 0, minus 5 into 0 is 0. Any number into 0 is 0. Okay, so we got the total of sigma dx dy. So we have got all the important totals, that is sigma x, sigma y, sigma dx square, sigma dy square, and sigma dx into dy. So these are all the important totals that we require. So this completes our table calculation. Any doubts in the table calculation? Any part you want me to teach once again? Any doubts here? Okay, good. So let us go to the next, that is formula calculation. Okay, now coming to formula calculation, we will do it similar to the previous ones only. Okay, but here the only extra step that we are taking is calculating the byx and bxy. This is the only extra step that we are doing here. Now let us go back here to the previous one. Now if you see this problem, it was from actual mean. So we calculated x, x square, xy. Okay. Now when it comes to regression equation, the formula for byx was very small. That is sigma xy by sigma x square for y on x. And for x on y, it was xy by y square. Okay. It was simple. So here we directly used it along with the formula. But when it comes to assumed mean, okay, when it comes to assumed mean, the formula for this byx is a little big. Okay, so first we will separately calculate the byx and bxy, and then we will apply it into the same regression equation. Are you all able to follow? This is very important thing you will have to understand and realize while solving the problems. Okay, here the differences in actual mean problems. In actual mean problems, that byx would be a small formula sigma xy by sigma x square, sigma xy by sigma y square. That's all would be the formula. So we were directly applying it here only. But for assumed mean, the formula is a little bigger. So that is why we will calculate this, and then this number will be applied into the equation. I hope I am clear with whatever I've been done until now. Yes, understood? So let us start the calculation. So what is the regression equation? First, for y on x. Y on x means y will come first. So y minus y bar is equal to byx into x minus x bar. Then regression equation on x on y. So x minus x bar is equal to bxy into y minus y bar. Okay, so this is the regression equations which we have been solving until now. Now for this byx and for this bxy, we will first find out the values. So let us do that. Byx is equal to n into sigma dx dy minus sigma dx into sigma dy whole divided by n into sigma dx square minus sigma dx whole square. So this is the formula for byx. For bxy, it is the same formula except the change in the denominator. Okay, only denominators are gonna change in both of them. For one it is x square, for one it is y square. Moving further, let us put or substitute all the values that we have calculated. So if you see, if you go back and see the totals here, sigma dx, dx square, dy, dy square, dx, dy, everything we have. So let us put that. N is equal to 6. We have 6 data. So 6 into 740, excuse me, 740 minus sigma dx is 5, sigma dy is 20. Okay, divided by n into sigma dx square. So if you see here, sigma dx square is 899 and sigma dx is 5. So sigma dx square is 899 and sigma dx is 5 square. Here also many of them will go wrong. They will not know the difference between dx square and dx whole square. So be careful in that. So 6 into 740 minus 5 into 20 whole divided by 6 into 899 minus 5 square. So this is on one side. Okay, so let us solve this. 6 into 740 is 4440. 5 into 20 is 100. 6 into 899 is 5394. 5 square is 25. So you will get 4340 by 5369. The final coefficient of this regression here is 0.8083. So this is byx. So any doubts in calculation of byx? Any doubts in calculation of byx? Any part you want me to explain it again? Yes or no? I want quick reply. Okay. Good. Now let us solve for bxy. So we finished this byx. Now let us solve for bxy. Now bxy, again the values. I told the numerator is same. So the values in the numerator also will be same. So 6 into 740 minus 5 into 20. Okay. Whole divided by, if we go back here, sigma dy square is 720 and sigma dy is 20. Right? So sigma dy square is 720. And then sigma dy is 20. So 6 into 720 minus 20 square. Next, 6 into 740 is 4440 minus 5 into 20 is 100. Numerator is same in both the cases. Coming to denominator, 6 into 720 minus 20 square is 400. So 4340 by 3920, the bxy, the coefficient, the regression coefficient bxy is 1.107. So this will be the regression coefficient that we found out. These are regression coefficient. Now let us apply this byx into this equation and bxy into this equation. Okay, so what we will do here is y minus y bar is equal to byx into x minus x bar. We already know what is y bar and x bar. Don't take assumed mean, take the actual means only. Here, for this calculation alone, you have to take actual mean. Okay, so y minus y bar is, which you calculated, 63.33 is equal to byx is 0.8083 into x minus x bar is 52.83. Okay, so we have just applied, or we have just written all of the numbers that we had with us. So y minus y bar is 63.33 is equal to byx 0.8083 into x minus 52.83 is the x bar. Now just simplify this. First we'll simplify this side. 0.8083 into x is 0.8083x. 0.8083 into 52.83 will give you 42.7. If you multiply these two numbers, you'll get 42.7. Okay, so now we have y minus 63.33 is equal to 0.8083x minus 42.7. Now in the next line, we will take y to one side and all the numbers to the other side. So y is equal to, this is y on x. Remember that always, it is y on x. So y will be on one side. So y is equal to 20.63. From where did I get 20.63? Minus 42.7 plus 63.33. If you do, you get 20.63. You get plus, not minus. Okay, so first write the constant and then write the variable. So constant is 20.63 plus 0.8083x is the second part of the equation. Okay, so that will give me the regression equation of y on x. Everybody understood this? Y on x? Any doubts in this part? Okay, now let us go to x on y. Now going to x on y, we will be calculating this equation here. So x on y means first x should come. So x minus x bar is equal to bxy, that is the regression coefficient, into y minus y bar. So x minus x bar is 52.83, that has come down here, is equal to regression coefficient 1.107. 1.107 into y minus y bar is 63.33. Then x minus x bar, x minus 52.83 is equal to, let us simplify this side. 1.107 into y is 1.107y, and 1.107 into 63.33, you will get 70.11. So if you multiply these two numbers, then in the next step, since it is x on y, x will be on one side and take all the numbers to the other side. So minus 52.83 will become plus 52.83. Okay. Now, if you add minus 70.11 and 52.83, you will have minus 17.28 plus 1.107. Even though it is in minus, put the constant first and then take the variable. Okay. Always put the constant number first and then consider the variable in the second place. Okay. So that is your x on y equation. And this is y on x equation. Now, going back to the question, obtain two regression equations. So we have got two regression equations. Then also find expected blood pressure of person who is 50 years old. Okay, so x is age, right? So they have given us x is equal to 50 years and they have asked us to find out y. Okay, now coming down to the answer, see the equation where you will be able to find y directly when x is given. It has to be this equation. Y can be found out directly when x is given. Don't go for this equation. Okay, so that will be y on x. So substitute the x here in the equation. That will be y is equal to 20.63 plus 0.8083x. In the place of x, substitute 50. And when you simplify, the value of y, that is nothing but blood pressure for the person at the age of 50 is 61.045. So you have to be careful in knowing how do you find the direct answer when x is given. In that case, you will have to consider y on x. Did you all understand? Any doubts? Any part you want me to repeat it again? Okay, good. Now, going to the next question. Given the bivariate data. Bivariate data means two variables are there, right? So that is called a bivariate data. That's all. Since there are two variables given, it is bivariate data. Fit a regression line of y on x and hence predict y if x is equal to 5. Okay, so we have to first fix a regression line. Regression line is nothing but we have to find the regression equation. And we have to find y when x is given, that is 5. Similarly, we have to also fit a regression line for x on y. We also have to find the x on y equation where y is given to us and we have to find out x. So in simple words, you have to find the both regression equations. Okay, now let us see how many data do we have. So what are the number of data? 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. So find me x bar and y bar here. Find the value of x bar. So to find the value of x bar, we are supposed to add all the x values, right? We are supposed to add all the x values and the total has come to 23. So 23 divided by 8. What is the answer you get? 60. 23 divided by 8. What is the answer you get? 2.87. Okay. Is that the right answer? 2.87? 875. Okay, correct. So you get 2.875. So which means X bar again has a point in that 2.87 or 2.875 you can consider. Now Y bar. So what is the total of Y? Total of Y is 16. So 16 divided by 8. What is the answer you will get? You will get 2 as the answer. Right? You'll get 2 as the answer. So for 1, you will get 2.875. For 1, you'll get 2. So instead of taking assumed mean for one and not taking assumed mean for another, it will not be good. So what we will do is, we will consider this problem under assumed mean only. So if you see the X bar, for 1 you will get point, for 1 you will directly get whole number. But you cannot solve it under both actual and the assumed mean. That's not possible. Okay, so we are gonna consider this problem under assumed mean and we will solve it. So did you understand the question first of all? Analyzing the question is very important. I've been repeating it over and again. Now let us solve this question in the same manner how we did the previous one. Okay, so here write down X, Y. We found the total of X and Y. We also got X bar and Y bar. Next, find the deviations. For this, you have to assume a mean. I told you can take any number. If you see here, some number are repeated. So for this problem, they have considered 3 as the assumed mean. It can be this 3 also, it can be this 3 also. No problem. You can consider any number out of X to be taken as assumed mean. When it comes to Y, they have taken it as 2. Though the actual mean is also 2, you can take that number from Y. That is nothing but 2. Okay, so let us find the deviations. For X, the deviation is known as dx. So dx is equal to X minus assumed mean, that is 3. So 1 minus 3 is minus 2, 2 minus 3 is minus 1, 3 minus 3 is 0, 5 minus 3 is 2, 1 minus 3 is minus 2, 1 minus 3 is again minus 2, 3 minus 3 is 0, and 7 minus 3 is 4. So once you find the difference between the X values and minus 3, you will get the deviations. And once you add the deviations, you get sigma dx, which is minus 1. Okay, so this is deviations from X. Now let us calculate deviations from Y. So deviations from Y, again Y minus 2. So the assumed mean considered here is 2. So that is why 6 minus 2 is 4. 0 minus 2 is minus 2. Again 0 minus 2 is minus 2. 1 minus 2 is minus 1. Again same number. Again 2 minus 2 is 0. 5 minus 2 is 3. And 1 minus 2 is minus 1. So here everything will get nullified and dy is equal to 0. So this will be the deviations that we have found out from X as well as Y. Next, after this, we have to find the square of the deviations. So this is going to be squared. So 2 square, 1 square, 0 square, 2 square, 2 square, 2 square, and 4 square. So you'll have 4, 1, 0, 4, 4, 4, 0, 16. Add them, you get sigma dx square is equal to 33. And similarly, for dy also square them and add them, you get sigma dy square is equal to 36. So this is squaring of the deviations. And finally, multiply dx into dy to get dx dy. So 2 into 4, minus 2 into 4 is minus 8, minus 1 into minus 2 is 2, 0 into minus 2 is 0, 2 into minus 1 is minus 2, minus 2 into minus 1 is 2, minus 2 into 0 is 0, again 0, 4 into minus 1 is minus 4. So we have multiplied dx and dy. And when you add dx and dy, you get sigma dx dy, which is equal to minus 10. Okay, this is equal to minus 10. So this is your tabular calculation. So any doubts in the tabular calculation? Can we go for the formula quickly? Okay. Now, coming to the regression equation. So this same regression equation, they have asked us to formulate both the regression equations y on x and x on y. Okay. Here again, since it is assumed mean, the regression coefficient you have to find out. That is nothing but byx and bxy. So we'll write the formula n into sigma dx into sigma dx dy minus sigma dx into sigma dy whole divided by n into sigma dx square minus sigma dx whole square. This is byx, x on y coefficient. Now coming to, sorry, y on x coefficient. Coming to x on y coefficient, the numerator will be same. The denominator n into sigma dy square minus sigma dy whole square. Let us put all the numbers quickly. So n is equal to 8 for us. Then sigma dx dy is minus 10 minus sigma dx is minus 1 and sigma dy is 0. Then denominator n into sigma dx square is 8 into 33 minus sigma dx is minus 1 and minus 1 square. So this is on the one side. Now simplify. 8 into minus 10 is minus 80. Minus 1 into 0 is 0. So this will not make any difference. Minus 80, I will take it below because this will give me the answer of 0. Then 8 into 33 is 264. Minus 1 square is plus 1. So 264 minus 1. Now is equal to minus 80 by 263. So you get minus 0.3042 as your regression coefficient for y on x. So this is one side. On the other side, you have to calculate the coefficient for bxy. So numerator will remain same as it is. So minus 80 will be the numerator. When it comes to denominator, 8 into 36 minus 0 square. So 0 square is nothing but 0 again. So 8 into 36 is 288. So the coefficient on bxy, that is x on y, is minus 0.2778. So that will be the coefficient here. Okay. Now that will be the calculation of regression coefficients byx and bxy. So any doubts in the calculation of coefficients? Can we move to the equations? Okay. Now, moving on to the equations, that is regression equations. So whatever equation we had here, we are fitting the equation. We are fitting the same equation. Okay, we know what is x bar and we know what is y bar. X bar, y bar, both we know. 2.875, that is x bar, and 2 is y bar. So y minus 2 is equal to this minus 0.3042. That has to be considered here as the coefficient into x minus 2.875. Okay, so this is the second part where we'll have to apply x minus x bar. Now simplify this. Minus 0.3042 into x will give you the same value. And then if you multiply this decimal value into 2.875, you get 0.8745. Then take this minus 2 to the other side, it will become plus 2, and your final equation is y is equal to 2.8745 minus 0.3042x. So this is the final regression equation of y on x. Similarly, if you take x on y, you have x minus x bar is equal to bxy into y minus y bar. Apply the numbers, and if you simplify here, this is the regression coefficient that is taken. So minus 0.2778 into y and then into minus 2. So since this is also minus and here also it is minus, minus into minus is plus. So you get a plus value of 0.5556. Now in the next step, this minus 2.875 will come to the next step. So that is, it will become plus. And your x on y equation will be x is equal to 3.4306 minus 0.2778y. So here you have got both regression equation y on x and x on y. Okay, understood x on y, y on x? Any doubts in the equation? I'll just quickly finish this last part before I end. Any part you want me to repeat it again here? Okay, now see the question once again, the last part of the question. Fit a regression line of y on x. We have done that, and predict y if x is equal to 5. So if x is equal to 5, if x is equal to 5, you have to find the value of y. So just in the place of x, substitute 5, and if you simplify, you get the y value as 1.3535. Okay, so this is for y on x. Now, similarly, they have asked us for x on y. That is, if fit a regression line of x on y, we have done this, and hence predict x if y is equal to 2.5. So, if y is 2.5, here y, if you see y, if you substitute 2.5, you will be able to get the value of x, that is nothing but 2.7361. Clear? Understood the problem? 14 marks, you can expect this problem for sure. 14 marks. Any doubts? Any part you want me to repeat it again? Okay. So we shall stop here for today and we'll continue in the next class. Okay.